Here's pre-calc. It's closure problem 3 CL 3-151, and it says Penny is approximating the area under the curve for the function f of x equals 2 to the x, and she writes the sum of the rectangles as this here. Scott, who's playing with his calculator instead of working on assignments, brags, "Since I know the endpoints of the interval are integers, I can tell you everything you want to know about your area by just looking at your sum. The following items are things that Scott knows about the area. Show Penny that you also know a lot of information by just looking at the sum." So letter A says, determine the number and width of subintervals. So I know the width of the subintervals is 0.4 because this isn't our first time working with these summations. So what you can do, and actually I drew a little picture. I try to just draw a little sketch. I know that y equals 2 to the x is going to kind of just go up like that. And I can see that the first x is 1. So I know I'm starting at 1. And I know that because this 0.4, we've been finding the area under the curve by adding up all the heights of however many rectangles there are. We add them up and then we multiply by the width. Instead of going height times width, and then height times width, and height times width, and height times width, and height times width, 5 times, or however many times you need to, it's easier to just add up all the heights and then multiply by the width. So we should know by now that this is the width of the rectangles. And it says that Scott knows that since it has to be an integer. What does he say? Since I know the endpoints are integers, he knows that the endpoints are integers, he can find out a lot. So I know that if I add 0.4 to my 2.6, that ends up exactly at 3. So I made a guess that my x's are in between 1 and 3, and then all I have to do is make sure that that's correct. So I just like to prove that I believe that that my x's are going between 1 and 3, my intervals 1 to 3. I actually just I just followed their pattern. See how they're plugging in, because this is 2 to the x, so they're plugging in their x's up here. And we're missing some of it, but we can count up. So I know they plugged in an x, or they plugged in a 1 for x, and then a 1.4, and we know we're I don't know, going up by 0.4. So if you add 0.4 to that, you get 1.8, 2.2, 2.6. And I know by my picture that I'm not going to use that 3, because if I start at 1 and that's the height, then that I've got left, and they're touching the curve at the left side, so they're left end point rectangles. So to get the area under the curve, I would use these 4. Okay, so and I see that it works out when I draw the picture. And I named them. It looks like in our book they've been wanting us to start with x sub 0 every time, so I just went along with that, and I got x sub 0, x sub 1, x sub 2, x sub, that's a tiny 3, and x sub 4. Okay, so so the width we just know, because it asks us determine the number and width of the subintervals. The width we just noticed by inspection that it's got to be 0.4 because of this 0.4 here, and because these are climbing by 0.4. How do I know how many rectangles there are? Well, I drew my picture, and then I saw, well, from 1 to 3, that's like 2, or in other words, this distance from here to here is 2, right? So you could just say like 3 minus 1, it's 2. And then I need to divide that by 0.4, like how many little 0.4s are going to fit in there? And if you take 2 and divide it by 0.4, I just did it on my calculator, I got 5. So I see that there's 5 little intervals of 0.4 in between 1 and 3. So that's the answer to letter A. And then letter B basically says, determine the domain of the interval. Well, I kind of already answered that. I can see that it's in between 1 and 3. We want X as the interval, like from here to here. We're trying to find the area of the curve that's between these two darkened lines here. I'll make them bigger. And then letter C says, write the sum using sigma notation. So sigma notation is this summation notation that we have. So I know, because we've done a few of these, I know that I'm going to start at 0. So I'm going to go from 0 to 4, because that's my x sub 0 up to x sub 4. And I know that I need width times height. The height's going to be given by 2 to the x. I need to generate some x's though. So I had to come up with like a linear equation to produce the 1 and the 1.4 and the 1.8. So I just thought of, I was adding 0.4 each time, and so I just think of like y equals mx plus b, like the slope's going to be 0.4. But in this case, since we're starting by plugging in zeros, we can just use 1 for our first, well, like, so I shouldn't say y equals mx plus b because, well, you can just check it, right? You can go, does this, so I want, when I plug in 0, I want to get 1. And when I plug in 1, I want to get 1.4. So let's just test it. Plug in 0. 0.4 times 0 is 0 plus 1. I got my 1. Okay, I'm going to test it again and see if when I plug in 1, let's make sure I get 1.4. 0.4 times 1 is 0.4 plus 1, that's 0.4. So I'm pretty sure that this thing is going to generate all my x terms. And so when I raise 2 to each of these x terms, that's going to give me my y values. Now, luckily, they're not asking us to get the sum, so I don't actually have to calculate all these y values and add them all up. I'm just supposed to write this notation here. So that's what that is. And then letter D says, were Scott and Penny using left endpoint or right endpoint rectangles? I felt like I needed to know that. I felt like I knew the answer to letter D right away when I saw this 1 here. So I'm going to say they were using left endpoint rectangles. I think that's all I got.